brain, so I'm going to have to allow hypertension. So as a nurse, not only am I watching my ABGs, I'm gonna have to watch my blood pressure, my mean arterial pressure, and I'm gonna have to keep that pressure high enough to perfuse the brain despite vasoconstriction. I'm gonna be giving you another calculation that you need. Now that you know how to calculate mean arterial pressure, we're gonna have to now watch intracranial perfusion pressure. So the brain has to be able to accommodate this, and we have to keep normal intracranial pressure. This is all governed by a doctrine. The book talks about the Monroe-Kelly doctrine, which really just says, in general, you have this constant volume in your skull. The skull can't change, so I have to be able to control the volume. There's only two components, really one component, that I as a nurse can control. I can't control the amount of brain tissue, and I really can't control cerebrospinal fluid. The only thing I can control is the amount of blood. And we can do that by causing vasoconstriction to occur using things like the respiratory rate. So, normal compensation, if I'm normally compensating, cerebrospinal fluid will either kick up to fill in pressure or blood will kick up to fill in pressure. So if I remove cerebrospinal fluid, your body's automatically going to adjust by increasing blood volume to the brain. So it, again, is constantly regulating itself. Or the body can alter cerebrospinal fluid absorption or put more cerebrospinal fluid back in. Before I talk about ICP, I want to give you this. Where is my? Somehow I have lost the slide that gives you the calculation. There it is. I found it. All right. In order to be able to calculate cerebral perfusion pressure, I need to know my intracranial pressure. So I'm going to go back and talk about how we monitor intracranial pressure, but we're going to take the math and we're going to minus intracranial pressure. And then we're going to get cerebral perfusion pressure. Cerebral perfusion pressure needs to be above, or we want it like at that 60%. If it is less than 30, the person is in cellular ischemia. So if we're even getting anywhere near 30, we're going to need to